Hi, Phaidra. Are you here?
Yeah, I'm here. Can everyone see me okay?
Yeah, we can see you. So this is Phaidra Campbell, and she is also a Cabrillo alum, but she studied engineering and then transferred to Cal Poly. And there she met a professor who set her on her current path. I think that's kind of the best way to sum up her educational and career path. And I think she's coming to us from Hawaii.
Yes, in the other room other than Dave. So Dave is my husband, and we actually just transferred out here on Monday. So last Monday for a project, which I'll talk about a little bit. But just maybe in how to get projects actually. So yeah, let me start my presentation here. Let me share my screen. Can everyone see my screen?
Not yet. Oh, not yet. I don't know. It's not shared yet. There it goes.
We have been having some internet issues. So yeah, we just got internet set up. So all right. So I'm a PE, professional engineer. I have certifications both in California and Hawaii. So about 14 years ago or so, I was actually in your guys's position at the Engineering 5 class at Cabrillo. And I actually, I was in the same courses that Dave was in, and I also transferred to Cal Poly in San Luis Obispo. And my general interest was in soil and geotech, mostly because I just like dirt. And that was just something that I was really into and I thought was really interesting. And I was also interested in structures. So and as Pretty said, I pretty much got my job and into the industry that I'm in now, which I'll talk about in just a second, because of a professor at Cal Poly. I was right about to graduate, and I was also part of the Engineers Without Borders group at Cal Poly, which I'll talk about a little bit. And I was in his office, and we were talking about EWB, and he was the advisor. And he said, "What are you doing after graduation?" And I said, "Well, I applied to a couple places, but and I mentioned like one of the places I applied to that I thought was interesting because I always kind of liked weird engineering jobs." And weird jobs in general. And I said, maybe tunnels, I don't know. And he goes, "I know a guy." And he literally picked up the phone while I'm sitting there in the meeting or just at his office. I was like, "Do I need to say anything?" And he's like, "No, just sit there." And so I was there listening to their conversation, and the guy he called was my first employer, who said, "Bring her on up." And so I moved up to Seattle, Washington, and started working in tunnels. All different types of tunnels that we've worked on now. So over 14 years working underground. Dave works above ground, I work below ground. In a lot of ways, my stuff is not barely ever in the public eye, except for road tunnels, which people, go through in light rail, trains, and also car tunnels. But that's really the only tunnel that the public actually sees. Although the public is a part of all these projects like sewer tunnels, drinking water tunnels, hydroelectric, they just don't really, they participate daily without even knowing it, especially like sewer tunnels. I mean, we use wastewater every day. And that's actually the interest that I had, is that it's kind of this like nobody knows about, nobody knows much about it, and nobody seems to care on a global level, but they actually do. We actually have so much that we integrate in terms of sewer and drinking water, and so it's really great to be part of an engineering system that is so crucial to day-to-day life, and that's what I really like about it. I also like that it's like you never really know what you're going to run into. And that's kind of the fun and excitement about it, is there's always some there's always something you're going to hit. Like in the Purple Line in LA, we've actually hit a woolly mammoth in the tar pits. So who would have guessed that we were gonna have like, you know, hit a actual fossil, a huge fossil like a woolly mammoth, which has been excavated and is going to be put in the station for the subway station. But it's just, it's all these kind of very strange, weird scenarios that we always come up with in terms of tunneling. Just a couple of pictures of tunnels that I've worked on, and if you can see my mouse, these are twin tunnels for roadway and then for subway, and then these are just for pedestrian walking paths. This is actually a water storage tunnels, and then these are cut and cover culverts. Here's some more tunnels. You'll see actually you probably have, if you've ever been up to Seattle or actually the multiple subway systems, I think BART in San Francisco, no, BART doesn't have it, but you'll see these segments. So these are actually built with a machine called tunnel boring machine, which I'll go through in just a second. This right here is a really cool mechanized shotcrete arm, and it's actually being controlled by a remote control. And so if you're really good at gaming or anything, you could say like, oh man, I can do that. It's pretty interesting. And we have these like huge pipe systems. And when I say tunnels, like I mean large diameter tunnels. I mean, these are like, you can work on small diameter projects, 2 to 3 feet, maybe even 4 feet. But what I really like to work with is anything that I can walk into. And I don't mind, you know, doing small stuff as well. But when you start to get in these grand scale projects where you're in 20, 40 foot diameter machines and excavations, it's just a whole nother ball game, and it's really fun and really exciting. And you get to interact with so many different types of people from all different backgrounds. And that's what's really great about engineering in general, is that you're not just sitting with a bunch of engineers. You're also sitting with hydraulics personnel, operations, people in marketing, people in finance, scientists. You have so many different people that you're working with, and you can learn so much from everyone, which makes it really fun. You know, one of the ways to excavate a tunnel is by blasting. And I thought I had a video, but I don't think I have it up right now. But basically you're drilling holes into the face and of a tunnel like this, using this drill here. And then you pack them with explosives. We're very safe, but it is very fun. I'll be honest that one of my most fun jobs I've ever worked on is where I got to send off a charge. And I'm a designer, so I don't usually, designers tend to not be the one to set off the charge, but I worked on site, because as a tunnel engineer, you design and then you have to go to the site to make sure that what you designed is actually according to what is going on. Especially because you don't know what you're always going to hit, that you kind of need to be on site to be able to make quick decisions and be able to, you don't get cell phone coverage in a tunnel. And so you have to make a quick decision about what to do next if you run into something that's an issue. And so I made friends with one of the superintendents, so I got to lay the charge, which is fun. And then the other method is using a road header, which kind of looks like a Total Recall movie, like machine that, you know, is kind of take apart the rest of the world. But it is a really weird machine, but it just grinds away what's in front of you. And then this machine is called a tunnel boring machine. This is like the most common machine that you would see nowadays. I think it has been getting a lot of press lately because there's companies coming out like the Boring Company who are kind of showcasing machines like this. But there are about 6 or 7 different manufacturers of tunnel boring machines all over the world. That's another thing about tunneling. The United States tends to be a little bit behind when it comes to building tunnels. The people who have been the most influential over the last couple centuries is Europe, Norway, France. They have the channel there between England and Paris, and you know, and actually also China and Japan. In Japan, they have you know, 2 TBM manufacturing companies. Germany has a Heron Connect. The United States does have one, but you know, and we're slowly up and coming and kind of considering that tunneling is a good way to go. Mostly because land is expensive. And so if we can go underneath and try to minimize the imprint, the footprint at least on the surface, it maybe is the better way to go, especially in terms of traffic. But how the machine works, and I'll just give you a quick lowdown, is this is called the cutter head, and the cutter head rotates, and it starts to score the ground as it moves forward. And so it's scoring the soil or the rock. And as the rock and soil gets excavated, it drops down to the base and what we call the invert. And then it gets pulled up through a conveyor belt, a screw conveyor, which is actually designed by Da Vinci. So we're using like technology that's been designed, you know, centuries ago, and we're still using them because they work. And then as the material goes through the screw, comes up, it drops onto a conveyor belt and then gets sent all the way out to where you have a shaft to get the material out. In soils, you have these things called segments that I was talking about earlier, these like concrete segments. And this actually gets built, the machine builds these and places them kind of like a puzzle. And then to move the machine forward, you have these hydraulic rams that pushes against the last piece of the segment. So it's almost like an inchworm, like picture a very slow inchworm. And it depends on how fast these things, how fast these things will go depend on the ground that you're in, how much water is above you. But on average, you could say probably like 50 to 70 feet a day in like poor ground, and up to 150 in good ground. It depends. It's very dependent. But it's really fun. And actually, I have a really great video I'll send you guys a link to that really describes how these machines work. And the great thing about these machines is I was talking about interfacing with different engineers. Like this is a mechanical and electrical engineering marvel, and mixed with a civil engineering and geotechnical engineering. And so you're meeting with so many different people about this, and then operations as well. I just want to give you a couple projects because as you drive around, and I don't know if anyone has been through in the tunnel, Caldecott Tunnel between Walnut Creek and Oakland, but I recommend to take Highway 24 and going through the Caldecott Tunnel, which is, there's 4 tunnels. 3 of them are on the southern side, and they are old tunnels. But the newest one is on the northern end. And so if you're driving from Oakland or Walnut Creek to Oakland, get in the right-hand lane and make sure you get into the new tunnel. And you can see the tunnel will look, let me look like this. So the phase 1 and phase 2, this is how the tunnel looks in your drive through on either side. I think I have a final photo of it. There we go, driving through. And this tunnel was excavated using a road header into a phase 1 and phase 2. And the reason why we did this is phase 1, we cut just the top because you could reach it, right? They're like simple concept, but but sometimes you don't think of the simple things. And that's one thing you always have to come back to, is if you're making engineering too hard, you might want to pull back a little bit and just see if you can see things in a little bit more simpler light. Because there is a simpler approach, and this is what our approach was: is see how we could actually do all the work at the roof by only excavating the top half. And then once this was done, the roof was done here, we were able to drop it and do the second half underneath. It's just a really like a simple way of solving that problem. The other thing I just wanted to pull out here is like, this is the lead up to the tunnel, and so you can see these benches. These in rock, you know, the best way to know what's going on geologically is just driving around and seeing what the cuts in the roadway look like. I mean, this is like one of the main areas that we were able to design the tunnel for, is because just walking out here and crawling up on the rock. So always look around you. The other tunnel project I've been working on, I know I don't have like a ton of time, so I'm going a little quick.
You're good, you're good.
Okay. The other project that I worked on, which is the Kaneohe sewer project in Oahu. So I worked on this project as a sewer tunnel about 6 years ago, and it was a great project. It's a sewer project. We threw in rock and soil, so we used a tunnel boring machine and a road header. It's about 4 miles, 15 foot diameters. We were about 800 feet underground, and the reason why I'm here in Hawaii now is because I worked on this project, and there's a new project that's coming up, a new sewer tunnel in Waipahu, which is down here, and the city and county who owns this project just called me up and said, "Hey, we got a new project. Why don't are you interested in working on it?" And that's actually how you get work. Is you do a good job on one project and someone calls you back later. And you always want to keep good relations with owners, with clients, and always be on, try to be on good terms with other engineering companies too, because you never know who's going to be your boss at some point or who is going to give you the next job. And this, ultimately, like, we moved out here to work on this next project because I had worked and have experience on this other one. So it's always good to use your past work as launching points for future work. And if you can get a company to back you into sending you, that's even better. Definitely. And I have some other things about that too. But so when we're first designing a tunnel, is you have to do a lot of drilling. And so we spent a lot of time just collecting rock cores, and it's like beautiful blue basalt. I just love this rock. And then seeing, like I said, driving around and seeing what kind of rock cuts are around here. Like, we just literally pulled off of the side of the road, started mapping this rock and using that to determine what our jointing would be down below the surface, 800 feet. I mean, there's a little bit more to it, but ultimately, like, we're just, we don't always have to drill holes. You could also, check what's on the road. This is the tunnel alignment. We started in Kailua. And then it's a gravity tunnel. So there's no pump stations, and it goes underneath this mountain range, and then it ends at the Kaneohe drop shaft. And then there's outlet here that goes over to the Kaneohe Bay. This was the tunnel alignment. So that's in plan view, right? This bird's eye view. And then if I took a cut and a cross section of that, this is what the cut and cross section would be. And so we were mapping, this is the 2 shafts, and this is where we started in Kailua, and then we drove the tunnel all the way through that mountain range, which the pink is in rock, all the way, and then this is in soft ground. So this is where we used the road header, was in soft ground, and then took out the machine at the Kaneohe side. So we first have to build the big shaft, right? This is like, we're going deep here, so you still have to do a big shaft, and this is really fun to do. And this shaft was called a slurry wall shaft. And so you pretty much build a trench, and you use bentonite to keep the sides from falling in on you. And you use these big machines called slurry wall machines, and they just grind up the material and suck it through a vacuum. And then you have a rebar cage, and then you trim the concrete from the bottom up. And so it makes these really nice concrete panels. Most panels never look this good. I'll just be honest that this one actually looked really good. And then here's the machine that we had. This is a main beam machine. This doesn't have a shield around it, but because we didn't need those segments, because we're in rock. You only really need segments when you're in soil. And so, and because we didn't have segments, we couldn't use the hydraulic rams to push against you. So we used hydraulic feet to push against the sides of the tunnel in order to inch forward. So these like just different ways of, adjusting the mechanical equipment in a machine to make it work. And so here you'd see like some of the joints that water comes through. Water is the worst thing for a tunnel. Some people say, oh, isn't rock hard to excavate? No. Rock is the best, unless it's jointed with a lot of water. So sand is the hardest, but really, ultimately, these joints we need to always pay attention to, which is why you drive on the side of the road and find out where the joints are. And, there's a lot of perks with traveling. The joke is there's never a tunnel where you live. And so you tend to have to travel a lot, which I am okay with. I really enjoy it. That's part of the reason why I was really interested in tunneling in the first place. So if you want to travel, this might be and experience new places. This might be an opportunity that you'd be interested in. And this industry needs people. So we're always everyone, especially right now. We're like, do you have people? We need people. So if you were looking for like, oh, some security for a job and to be able to travel, it is a good opportunity. Just wanted to quickly go through some of the opportunities that I've had with Engineers Without Borders. There's something that I've always been interested is just being involved not only on engineering and work side, but also in my civil responsibility. And, I'm really passionate about doing international and local aid work. I want to make sure you include local aid work because it's always important where you live to reach out to your local community. But, when I was with Engineers Without Borders, I had worked in a project in Thailand, and this is a couple of my old colleagues in school. And we were working up in the mountains and we were building a slow sand filtration system. I mean, this has nothing to do with tunneling, but as engineers, you tend to have that critical thought process. And that's what you're in this engineering 5 class, you're in engineering 10 and 25. And the whole goal of those classes is to try to like help you think critically and help you like come up with this idea of how to form solutions, problem solving capabilities. And so just because it's not in your field doesn't mean that you can't do it. You might not be the perfect person for it. You might need help with it, getting the experts, but you can have this ability to really solve problems. And once you get your degree in engineering, believe me, everyone's going to call you and ask you every little question about everything. My mom calls me when anything mechanical or structural goes wrong. And so, and not that I have the right answer for everything, but I usually, as an engineer, you usually try to get there. You usually try to solve problems a little bit more. So it's just, you can use your abilities for other things, such as doing work outside of your realm. And it's always important. You get such great perspectives from doing these projects. And it also is a lot of fun. And then, so I did also a project in Nigeria, doing a orphanage support center. And I was part of the survey team and survey crew. I just love this landscape with these huge boulders. They're just absolutely fantastic. And we collaborated with local workers too, and it was just such a great opportunity. And some of the kids got involved too, which is always really fun. When you travel, is like seeing like the local kids just get really excited about what you're doing. And so we were helping do some designs, and then we were doing some water, definitely some water comparisons using, I don't know if you ever use pure water, lost my train of thought, chlorination, but it's like the black is just regular from the house and the well, and then we treated it with pure, and then that's it cleaned it up within 24 hours. And then we also did another test at another well. And so these like, it's just amazing to be able to travel and see some of these things and realize like how these things like pure really are important for the health and safety of communities. And then there's always some fun like running around. And so then we would also be working on some wells, which is really great. So I've also worked in Iquitos in Peru on the Amazon River, doing a stormwater collection system. And this was a fantastic place. I actually did this with EWB as well. The other project that I did in Nigeria was with EMI and a different engineering outreach group. And I actually still work with EMI, and I go to Uganda every year to do projects with EMI. However, last year I didn't get to go. So this year I hope to go. So that'll be my 4th year going. But this project is in the Amazon, which there's like, it's pretty epic. It's pretty amazing. We were, going to these small communities and working with the locals on building these rainwater catchment systems. And such great people. I learned so much on this project, because this is, like I said, this isn't my wheelhouse, but, building the frames is, but, I learned so much about these systems and how the locals use them. And what's great is, like, I was really influential in designing this platform because Amazon floods every year, and the water level actually gets up to here. And so they still need to get water. And so we had to, just make sure everything was designed appropriately in order to make sure they got water during the rainy season, and they used their canoes to get their water. And we have a training course for the locals. And then we actually I haven't gone back here, but this team goes back every year to make sure all the systems are working. And we have about 8 systems right now. And we've actually gone through and started training the local crew to, and actually this guy, Jose, he's been influential. He lives there, and help training locals to build them themselves, and helping getting the resources financially in order to do that, in order to drink clean water there. These are previous systems that they check on every year. And of course,
how would students get involved?
Through EMI, so EWB is the perfect way that students can get involved, because EWB is like designed for students. And if you're interested in this kind of stuff, make sure you look at universities that have EWB programs already set. I was like I helped start the first EWB program at Cal Poly. And not that I wouldn't recommend like going to a university that doesn't have one and starting one, but it's a lot better if you go to one that's already set, because they're already working in the communities and they already have things going. And so if you're really interested in it, go to a school and just call them up and start going to their meetings and just get involved. It really will help change your life. It really will help you see things in a different perspective. It'll make you a better designer. And more sympathetic to the situations and how to design in such different environments. I mean, you have so many different things that you have to consider that you don't hear in the comfort of your own home. EWB is the first one, and then as you graduate college, you could look at other organizations like EMI or EWB professional chapters, which they do have professional chapters that you can move forward with. But it is so rewarding, and you really gain friendships for life. I keep in touch with people all over the world because of this. And now that we have like social media and everyone has cell phones, which is fun, because I keep in touch with Jose through text, and he doesn't get cell phone reception everywhere, but, so we always just keep in touch with one another. Or WhatsApp is usually what we use. But yeah, then we found this crazy snake. And then there's me pretending I can lift up one of those, the huge chainsaw. And yeah, it's just an amazing place. And I give you these pictures to like encourage you, because you're not just doing engineering the whole time. You're like visiting with people and community, people are interested in why you're there. And so they're always like, what are you doing here? And so you share things about your life, pictures of your friends and your family and, where you live. And then they share things with you, like their local food and celebrations and learning just like, oh, this is the tree that you cut if you're thirsty and you're in the jungle, and just, it's really amazing. It's just a really unique opportunity. So I want to encourage you all to do that.
I think Cabrillo also has an engineering abroad program, right? So
yeah, so I I'm sorry, I was actually on one of their projects in Guatemala. So I helped lead one of the student groups to Guatemala the last year we went to Guatemala. Yeah, it's just an amazing opportunity. I recommend seeking that out as well. And that would be great because EWB is more universities, or this program is for community colleges. So that it just really gets your feet wet into it. So I would highly recommend trying to be involved in that.
Yeah, great. Thank you so much, Phaidra. I want to give students an opportunity to ask you questions.
Yeah, definitely. And I'll also give my contact information, and if anyone, did I hear, I can probably do that. And
I have the video on the heron-necked tunnel boring machine. Is that the one you're talking about?
Yes.
Okay, so that's published in the module now. So,
okay.
So we have a question. How do you hold up loose rock and dirt while making tunnels?
That is a great question. You use a support, what we call a SOE, or support of excavation. And I'll show you a quick one of that. This one, this is a good one. So this is a support of excavation. So you use ribs, steel ribs, and boards to connect those ribs. And if the ground gets, this is in rock. And so if the rock's really bad and jointed, you would use these. And if the rock gets worse and worse, you tighten them up and you make them short, you make the distance shorter and shorter, so the ground can kind of bridge between them. If the ground's worse, like this is actually a winery. And so we do a lot of winery projects. I haven't done any recently, but I used to do them quite a bit. And then, so these are those ribs, but you use shotcrete, which is what
you just had it, the arm.
Yeah, it was like spraying. And shotcrete is a mixture of cement, water, and sand, and small pea gravel. So it's like concrete, but not with a big aggregate.
I think Crystal has a question.
Yep.
Yeah, I was wondering what the training process was like after school, like after you got out of school. I imagine that you didn't like take a bunch of classes around the tunneling. Did they teach you a lot? Did they expect you to know different things? Like, how was that?
That's a really good question, Crystal.
Transition.
Yeah, that is a really good question. So you're right. I didn't know anything about tunneling when I was in school and when I got out of school. Cal Poly does have after I graduated, they started doing like a couple tunneling classes. And it was and I went down and have taught a couple. They're kind of like one-off classes. They're not like full-blown classes. And there's only a couple schools in the US who actually have tunneling courses. I think Virginia Tech and Colorado School of the Mines. They're more internationally, definitely more in Norway and France and Germany. But when I got hired, in this industry, people just tend to not have any experience when they come out of school in this industry. And so typically you'll get put with a mentor. If it's a good company, you'll get put with a mentor who's been doing this for a long time, and you absorb as much as possible. And you usually get thrown onto a construction site. And the first year, I would say the first 2 years, you are just trying to get a grasp of the scale of these projects. I mean, these projects are huge. These are multi-million dollar, hundreds of millions of dollars, sometimes in the billion-dollar projects. And so you're not going to know anything coming out of school, and you're going to have to be okay with that, and and be a little humble about it, and really learn from others. I had like multiple mentors when I first got out of school and started working in the tunneling industry. And I did have to learn on the fly. Being in a tunnel and not having cell phone reception, and my first year being so green, I had to depend on contractors. I had to depend on anyone who would help me out if I had questions. And sometimes I made a lot of mistakes. You do have to learn like the Cal Poly's like slogan is learn by doing, and that is the tunneling industry, is you got to learn by doing. And so you're not expected to know everything, and you won't, because you won't know everything coming out of it. I mean, I'm learning in my roles now, I'm learning tenfold now. And my bosses who are, I work for a company called JCK Underground. I think my shirt says my JCK Underground. And we're about 20 employees now. It's my second tunneling company I've worked for. My first one has about 300 employees. My bosses are in their 60s and they're still saying, gosh, there's so much to learn, you know, and it's true. These are not like a house where you can like tend to like, okay, I think I can design this. This is pretty simple. Like we have a box and a roof, and unless you get more like what Dave does in architectural stuff, there's more variance. But in tunnels, every project is different, every single one of them. And so you're learning like so much on every project. And it's great to see people who are even retired and are saying, wow, I've never seen this before. It's really fun. It keeps you on your toes.
How is that now that you're in a smaller company? How do you like that as compared to the larger one?
So it depends on what you like. I love smaller companies. I've always liked smaller companies. I like to know everyone's ability in the company, because I lean and depend on everybody a lot. So I would prefer to work for a smaller company where I can just call up the principal and say, hey, I have this problem, or I need some recommendations, or what do you think about this? When you get to bigger size, it's a little bit different for everybody, but I think it's around the number of 60 or so, maybe 60 or 80 is when you start to lose a little bit of that relationships and connections with some of your coworkers. Because there starts to be too many people and you start to lose just that one-on-one interaction. And so I tried, and when I started my old company, it was around 40 people, and we just built and pretty much exploded with 400. And I still keep in touch with them. They're still really good people, but and actually my company that I work with now, a lot of them used to work there. So which is the same way of just, you know, continuing good relationships and, you know, providing good work and just keeping communication with people who leave, and never show animosity for people who leave either, you know, because you really don't know who's going to be your boss next. So I prefer a smaller company, a lot more flexibility. I mean, I've been working from home way before the pandemic. I mean, that was for 3 years before the pandemic. So we were pretty set to always work from home and just travel when we needed to. Good question.
Thank you. Thank you so much, Phaidra. Are you quarantining right now since you just arrived?
No, if you fly to Hawaii, or at least in Oahu, you can take a negative COVID test 72 hours before your flight. And if it's negative, then you don't need to quarantine.
Oh, nice.
Although I will say that, so I'm like in the process of doing business development where like I'm trying to meet with potential clients, and there's a couple of different new tunnels other than the one I'm pursuing is for the Army Corps of Engineers for flood relief tunnels in Manoa Valley. And it makes it difficult. COVID's making it a little difficult just to foster those relationships. And so I'm giving, and I've talked with them and I was like, well, I'll give you 12, if it's okay, like let's do 12 days after I arrive, just to, you know, be considerate. And most everything's online, just online meetings and Zoom meetings lately. But in Hawaii, it's a little bit, everyone's so much more willing to be outside because it's warm. So even like outdoor lunches are more favorable at this point.
Cool. Well, I want to thank you so much for being with us today. I think you and Dave really inspired the class on unique opportunities that are available in civil engineering.
Yeah, we took like two kind of different paths. They're not very typical. And I hope that it has helped people just see that there's other things other than just the homes or small pipelines. That you can get large scale or you can get a little small and minutia as well. So there's so many different avenues to take, and whether you take more traditional, it's all good. It's just like learning that design process and that problem solving techniques is so crucial and important.
And taking the opportunities along the way to get experience, like you mentioned, with the engineering abroad and all of that. So
I always tell people the first 5 years of your design work, pretty much say yes to everything. Every project, say yes, like, because you will get so much experience within those 5 years if you're just willing to, if you're able to and willing to travel for work on hard projects, work in the middle of nowhere, and you will gain that knowledge so fast. And then you'll be someone that people will want to reach out to, which is good. You want to be that person.
Great. Well, thank you. And you're affiliated with Cabrillo, right? Do you teach a class at Cabrillo?
Yeah, I used to teach the surveying class, engineering surveying. I taught two semesters or two semesters of that. And yeah, I think with moving and everything, it was a little tough for me to continue that. And then working full time, it was really, I was having a hard time juggling it. But it was great, a great opportunity, and I really love Cabrillo. So,
well, maybe we'll see you back there one day.
That would be great.
All right. All right, we're gonna go ahead.
Oh no, yeah, just let me know if you have any questions and if you want to reach out. It'd be good.
Sounds great. Thank you so much, Phaidra. Have a great day.
All right.
We'll see you later today.
Okay, take care.
Okay, bye-bye.